Okay, so let's try one more like that. Okay, so here we've got another argument with three different predicates, but instead of being in English, it's just in the logic of our predicate language. So we just have the symbols to work with here. Now the nice thing about that, of course, is that the predicate letters correspond directly to the letters in the circles. So in some ways, it's a little bit easier. Okay, so let's clear this out. And again, we're given a diagram here that represents the premises of this argument. So let's go ahead and make sure that diagram is accurate. So the first premise, for all x, if ax, then bx. So everything that's an A is also a B, according to this premise, right? For anything we pick, if it's in the A circle, it's also in the B circle. So that means that these two regions that represent A's that are not B's, the parts of the A circle that aren't in the B circle, those have to be empty. So we'll go ahead and shade those in. So now the second premise has this existential quantifier here. Right, so instead of shading something in, we're going to be putting a star somewhere. So this says there's something that's both a B and a C. Right? There's some x such that bx is true and cx is true. So something's in the B circle and the C circle. So we need to put a star somewhere that's both in the B circle and in the C circle. Well, that's these two regions here. That's the overlap between the B circle and the C circle. So the star has to go in one of those two, but we don't know which one. So again, when we have a situation like that, we just go ahead and put the star on the borderline to show that it's in one of those two regions, but we don't know which. So it looks like the diagram does represent what the premises say. So now let's see what the conclusion says. The conclusion says there is an x such that ax and cx. So there's something in the overlap of the A circle and the C circle. So let's take a look at what those regions would be. So the A circle overlaps with the C circle in these two regions. Now this one is shaded in. So wherever this star goes, it can't go in here. So it could go in this center region where all three circles overlap. But it could also, so that's the only place that this star could go, the star that makes the conclusion true. Right? It would have to go in this overlap between all three circles. Now, the premises don't tell us that there's definitely something in that region, right? The premises tell us that there's a star either in that region or this one next to it, but they don't guarantee that there's something in this center region in the overlap between A and C. So again, this argument's going to turn out to be invalid because the information in the premises doesn't give us enough information to know that the conclusion is true, right? The premises don't rule out the star being in this region that is a C and a B but not an A, right? The premises don't rule out this star being over here. They don't guarantee that there's a star in the center region. And if you sort of think about what these premises are saying, that kind of makes sense, right? The first one says everything that's an A is also a B, and there's something that's both a B and a C, but that doesn't seem like it would guarantee that there's something that's both an A and a C. And as you can see from the diagram, that turns out to be the case. So this argument is also going to be invalid. Okay, last kind of question that you'll run into are questions that ask you to use a Venn diagram but don't give you the diagram to start out with. So you're just going to have to draw your diagrams on paper for this. That really is the best way to do it. As you'll see, there are some limitations to the method that I'm using to put this on video for you. So let's take a look at this argument. All cats are mammals. All mammals are courageous. Therefore, all cats are courageous. So we've got three different properties here, right? We've got the property of being a cat, the property of being a mammal, and the property of being courageous. So we're going to need three different predicate letters. So we're going to need three circles to make our Venn diagram. So let's go ahead and have A represent our cats, B represent our mammals, and C represent our things that are courageous. And then we need to represent the premises and see if they give us enough information to guarantee that the conclusion is true. So the first premise says all cats are mammals. So if A is our cat circle and B is our mammal circle, then all A's are B's. So we have to shade in the parts of the A circle that aren't in the B circle. which would be these two regions right here. Second premise says all mammals, that is all bees, are courageous, that is they are Cs. So everything that's in the B circle is also in the C circle. So that means if you think about the B circle and the C circle, we have to shade in all the parts of the B circle that aren't in the C circle. So that's going to be this region and this region, right? We leave only the overlap between the B circle and the C circle, which is these two right here. Okay, so that's what the premises tell us, that these four regions are shaded in. Now the conclusion says that all cats are courageous, so everything in the A circle is also in the C circle. So what we want to do is look at our diagram now that we've filled in the premises and see if that has to be true. And if you look at our diagram, you'll see that the only part of the A circle that's left is also in the C circle. So this conclusion has to be true. Anything that goes in the A circle, that is anything that's a cat, is also going to go in the C circle, that is it's also going to be courageous. So the premises in this case really do force the conclusion to be true. So this is a valid argument. Okay, same sort of question, except now again this one's just in the language of our predicate logic. So we don't have English words to work with. And in this case, our predicate letters don't perfectly correspond to the names for our circles. But of course, if you're making your diagrams on paper, you can name your circles whatever you want to keep things simple for yourself. So the same idea, we want to fill in the information from the two premises and see if the conclusion has to be true. So let's start with the first premise. The first premise says for all x, nx. So everything is an n. So let's go ahead and use A, or circle A, to represent the n's, whatever those are. They can be narwhals if you want. You can pick anything. So this says that everything is in that A circle, which means we shade everything that's outside the A circle. So we'll shade this part of the B circle that's not in the A circle. We'll shade this part of the C circle that's not in the A circle. And we'll shade in this part of the B and C circle that's not in the A circle. Oh, and actually, this is the wrong kind of diagram. If you take a look at this argument, you'll see that there are only two predicate letters, right? All we have are N and O. So really, we don't need three circles here. We only need two circles. One for N, one for O. So let's start over. So first premise, for all x, nx, that means everything's going to be in this A circle. So we rule out all the B's that are not A's. And we have to remember to rule out all the stuff that's outside of both circles. Right? All this stuff that's not an A or a B, or in this case an N or an O. Right? If everything is an N, everything is in this circle on the left, then we have to rule out that stuff too. Second premise says that there's something that's both an N and an O. That is, there's something that's in the left circle and the right circle. Something that's an A and something that's and also a B. Okay, so that says that there's something in this area of overlap between A and B in this center region here. So if I could make a star in this little diagram, I would put a star here. You doing your diagrams on paper should put a star here. So we have these two regions shaded from the first premise, and we have a star to show that there's something in this center region. So that's the information we get from the premises. And we want to know if that guarantees that the conclusion is true. So the conclusion says for all x, Ox, so everything is an O. So again, our circle B corresponds to the O's, so this says everything is in the B circle. Well, we've got these two regions shaded, and we've got a little star here that I can't draw, but remember that it's there. Now, does that tell us that everything has to be in the B circle? Well, no, because we've also got this nice big region of stuff that's in the A circle, but not in the B circle. And there could be stuff in here, right? The premises don't tell us that that region is empty. We don't have enough information to shade this in, right? We shouldn't do that. So there could be some stuff over here, and that wouldn't be in the B circle. That is, those things wouldn't be O's. So it just doesn't follow from these two premises that this conclusion that everything is an O is true. So this argument is going to be invalid. And we can go ahead and submit our quiz. And unless I made some other mistakes, oh good, I didn't. I got all the answers right. Fantastic. Okay, so those are the various ways that you can use Venn diagrams to answer questions about predicate logic in Canvas.